Okay, so we're going to review proofs, and we're going to do just a bunch of mixed different problems. So you're not going to know which theorem you're using. You're going to have to actually mark it on the picture. And then we're going to use something called CPCTC, which we've mentioned, but we haven't used to prove anything. Alright, so our learning target is I can write proofs. Alright, so here are the theorems we've talked about. We have SSS, which is when you have three sides. SAS, a side, an angle in between, and another side. ASA, an angle, a side, and an angle. The side has to be between the two angles. Angle, angle, side. So angle, another pair of angles, a side, not in between the two angles. And then HL, which is only for right triangles. So I want you to pause the video, and I want you to write as many statements as you can think of for number 1. So obviously you got some givens. You're going to be using the fact that you have midpoints. You might be using another vocabulary, and then you're going to do a proof. So go ahead and at least write down the givens, and then think about something maybe you could use from definition of midpoint. Okay, so I know that I'm going to be using the definition of midpoint twice, because notice it gives me two different statements. So I'm going to use, I'm going to use the definition of midpoint for the fact that it's the midpoint of Kn. And then I also know I'm going to be using the definition of midpoint for the fact that it's the midpoint of MP. Alright, so if you know what a midpoint is, you should be able to figure out the statements. If L is the midpoint of Kn, then these two sides must be congruent. So KL has to be congruent to LM. If L is the midpoint of MP, these two sides must be congruent. So ML has to be congruent to LP. So we've stated that we have two pair of sides. The only other thing I see going on in this picture is a pair of vertical angles. So I'm going to state the vertical angles. So MLK is congruent to PLN. And my reason is that they are vertical angles. Alright, so notice in the picture, you have a side, an angle in between, and a side. You have used the side angle side theorem. Use the picture to figure out what theorem is going to work. Usually only one theorem is going to work. And then, just like they always have been, your last proof statement is what they were trying to get you to prove. Alright. I want you to try this one. I want you to write as many statements as you can think of, and then we'll talk about which theorem we use. Maybe you can do the whole thing by yourself. That'd be awesome. If you need a little help, you can push play and I'll talk you through it. Try it in 1, 2, 3. So at the very least, just from reading the problem, you should be able to state this. Now, if I use a little brain power, if I use that definition of bisect, my next statement needs to be definition of bisect. Actually, we're going to put angle bisector. Alright, if it bisects ABC, then these two angles are congruent. So that's going to be my next statement. So ABD is congruent to angle CBD. And then they're also sharing this side. So I'm going to say BD is congruent to BD. So because I wrote it like that, then I'm using the reflexive property. You could also use the symmetric. You just have to make a little bit of a different statement. So I think the hardest part is figuring out which theorem did you use. You had an angle. You had another pair of angles, and you had a side not in between it, so you used the angle side theorem. If you did that whole thing yourself, pat yourself on the back, that is awesome. If you're having problems, just keep trying and see if you can get it. Alright, so I want you to pause the video and do as much as you can. Try this. 1, 2, 3. Alright, so with not even thinking mathematically, you could make these statements right here. the fact that you use the word midpoint lets you know that your next reason needs to be definition of midpoint, and then you need to be able to make up a statement because you're using the definition of midpoint. So if it's the midpoint of QU, that means these sides are congruent. So QS is congruent to SU. If you had these in a different order, completely fine. But there's only one theorem that you can use. Notice that you stated 3 sides are congruent to 3 sides. That is your SSS theorem. Alright. So I want you to pause. See if you can come up with as many statements, many reasons. If you get stumped, just push play. We'll talk it through. 1, 2, 3. Okay, so my bad. Got a little trigger happy with the table. You only need 4 statements and 4 reasons. Hopefully you can get this. Because it's talking about a right triangle, we know that the only theorem we're probably going to be using is HL theorem. Alright, and then you should be able to see that they're sharing this pair of sides. So FH is congruent to, I'm going to just do FH because I like reflexive more than symmetric. Alright, that one's pretty easy. Alright, so now let's look at something called CPTCC. And we're going to talk about how we use it in proofs. So this stands for corresponding parts of congruent triangles are congruent. And I know that makes no sense, so here's what it's talking about. We're going to use CPCTC when asked to prove parts are congruent. So if a problem ever asks you to prove that a pair of sides or a pair of angles are congruent, you're going to use CPCTC. But first, before you can do this, you have to prove the triangles are congruent in the same way that we have been doing with those theorems that we've talked about. Okay, so look at this one. The only difference is we're not looking to prove triangles are congruent. We're looking to prove these 2 angles are congruent. So anytime it asks you to prove certain parts, we're going to use CPCTC. Okay, but before we can use it, we got to prove the 2 triangles in the picture are actually congruent. So go ahead and state your givens and do your reasons and mark your little picture. Okay, so hopefully you also see that they're sharing this side. So I'm going to say AC is congruent to AC, and that's because that's the reflexive property. And then we need to state that those 2 triangles are congruent, so we need to come up with a congruent statement. And remember, you can do this multiple ways. You just have to make sure that they correspond. I'm going to just say ABC is congruent to triangle A, DC. Yes, so those correspond with each other. And the reason I can say that is I have stated that you have 3 sides. So side, side, side there. Alright, so it's the same proofs that we've been doing, just the last statement is going to be what we're trying to prove, and then we're going to use CPCTC. Alright, so I want you to do as much of this as you can, pause the video and try it, and then we'll talk about it. 1, 2, 3. Okay, so the very first statement tells me I have parallel lines. Remember, if I see parallel lines, I'm looking for corresponding same side interior, alternate exterior. I'm going to use these angles. So I'm going to use angle RQS is congruent to PSQ because I know that those are alternate interior angles. And if you're having trouble coming up with these angles, then go back and watch the video on parallel lines and the angles that they make. And I'm going to label it right here and right here. I also see that we are sharing this side. So QS is congruent to QS, and that's your reflexive property. And then I've made enough statements that I can prove that the triangles are congruent. So I have an angle, another angle, and a side that's not in between. So I'm actually using the angle side theorem, and I just need to write my congruent statement, which just needs to make sure that we're corresponding. So I'm going to say triangle PQS is congruent to triangle RSQ. Now your statement right there can be completely different as long as they're corresponding with each other. Okay. Alright, I want you to try this one. Do as much as you can, and then if you get stumped, you can play it. But pause the video and try it. 1, 2, 3. Okay, so you should be able to at least come up with that. I have two different midpoint statements I'm going to make, and both of them are going to be definition of midpoint. And I think some people just forget that if they make, like if there's two things that it says it's the midpoint of, to make two different statements, and sometimes that's what people mess up on. So if x is the midpoint of wy, then these two are congruent. So wx is congruent to xy. And then if x is the midpoint of vz, then these two are congruent. So I'm going to say vx is congruent to xz. Alright, so hopefully you noticed that you also have a pair of vertical angles, because they're intersecting lines and the angles are across from it. So I'm just going to state those really quickly. Let's see, I'll call them angle WXV and angle YXZ. And then I actually have said enough that I can prove that the triangles are congruent because I have a side, an angle in between, and a side. So I can use side, angle, side. And then I just need to make a congruent statement. So I'm going to just WXV is congruent to triangle YXZ. And once again, statement number 5 can be different as long as it's corresponding. Alright, let's just do a couple more, and then I think you'll get this one. So try as much as you can, and 1, 2, 3. Okay, so if I use the word bisect, then I have to use the definition of angle bisector. And so I'm going to say angle KJM is congruent to angle LJM. And then I can mark that on my paper. And then also I noticed that they're sharing that same side. So I'm going to say JM is congruent to JM. And if I state it like that, then I have to use reflexive property. You can make a different statement and use the symmetric. It's the same idea. And I have said enough that I can say the triangles are congruent. So I have an angle, a side in between, and an angle. So angle, side, angle. And then I just need a congruent statement. Alright, let's do one more. Try as much as you can. This is the hardest one. Got 7 statements, 7 reasons. See what you can do. 1, 2, 3. Alright, so I used the fact that I had parallel lines, so now I need to be looking for a set of angles. So alternate interior, same side interior, blah, blah, blah. Angle E and angle C are congruent because those are alternate interior angles. I'm getting tired, so I'm going to abbreviate, being lazy now. The fact that I used a vocabulary word means I need a reason to be that vocabulary word. Definition of midpoint. Alright, if D is the midpoint of BF, then these two are going to be congruent. So BD is going to be congruent to DF. Another thing that I notice is that I have a set of vertical angles. Alright, so I'm going to name those angle BDC. It's congruent to angle FDE. And I can state that the triangles are congruent. I have an angle. Let's see. Sorry, I didn't label my C and E, which is why I can see it. So I have an angle. I have a side that's not in between, and another pair of angles. So this has to be angle, angle, side, and then I just need a congruent statement. I'm going to use BDC is congruent to FDE. So hopefully these make a little more sense now. If not, you need to ask or watch the video again or watch some other videos. Do something because this is a big deal. Alright, let me know if you have any questions.